Hi everyone, we want to talk about different chart types in the following few lectures. The charts that we'll cover exist in all data visualization technologies such as Excel, Tableau, Python, R, and D3. We are going to learn about a number of basic and advanced chart types. We will learn how these charts encode data and how they can be used, and we will see examples of the charts that we introduce. Our focus will be on bar charts and bullet charts in this lecture. We can have more than 100 different types of charts. Some are simple and some are pretty sophisticated. If we narrow down these chart types by just one level, we'll end up having the 40 chart types that I'm showing here. Some of them should actually look familiar to you. Some of these 40 charts are fairly complex to construct in Excel, but they can all be made in Tableau fairly easily without playing a lot of tricks. Of course, all of these can be plotted using libraries that programming languages such as Python, R, and JavaScript offer. 24 of the charts in the previous slide are directly available under Tableau's Show Me option, and the rest of them can be achieved by modifying one of the available chart types. Chart types that are not applicable to our worksheet, the way it is currently constructed, will be grayed out and not selectable until we have the appropriate combination of categorical and quantitative variables. The 24 charts that Tableau directly supports include text table, heat map, highlight table, symbol map, field map, pie chart, horizontal bar chart, stack bar chart, side-by-side bar chart, tree map, circle view or dot chart, side-by-side circle view, line chart, dual line chart, area chart, scatter plot, histogram, box and whisker plot, Gantt chart, bullet graph, and packed bubbles or bubble charts. Okay, let's start with bar charts. A bar chart is great for making categorical comparisons. Since bar charts use height or length as their pre-attentive attribute, they are great for precise quantitative comparisons between different categories. Here are two examples of bar charts that encode data with height and length of the bar. Note that the height and length are measured with respect to a common baseline. This or this in this plot. It is strongly recommended that the common baseline starts at 0 for bar charts. A lollipop chart is a handy variation of a bar chart where the bar is replaced with a line and a dot at the end of it to highlight the data value. Just like bar charts, lollipop charts are used to make comparisons between different categories. Here is an example of a vertical lollipop chart showing sales for different categories of products. The common baseline, as you see, starts at 0, which is good. If we have many bars, using lollipop charts can help us avoid the Moir effects that we typically see on crowded bar charts, as you see here. In general, crowded bar charts are visually aggressive, especially if they have bars that are almost the same length. So we would be better off converting this into a horizontal lollipop chart, and is better to sort the bars when converting into a lollipop chart. Lollipop charts are not ideal when there are unsorted bars of very similar length. In those cases, it becomes very hard to compare the length of two very different lollipops as opposed to the length of standard bars. That's because the center of the circle at the end of the lollipop marks the value that it represents, but exact location of the center is difficult to judge. Another variation of bar charts is called side-by-side or group bar charts. They allow us to compare groups in each category of our data. Different groups are displayed with a different color for easier comparisons. This is an example where the categories are different animals, namely giraffes, orangutans, and monkeys. The two groups that we are comparing against each other are San Francisco Zoo and LA Zoo. So we are comparing the number of these animals between San Francisco Zoo and LA Zoo. Okay, in side-by-side or group bar charts, color is used to differentiate the bars from each other and allow for a relative comparison. Notice that the bars at the bottom allow for precise comparisons, but the bars at the top cannot be easily compared because they do not have a common baseline. From these stacked bar charts, we achieve some part-to-whole idea about the data, but at the expense of that, we lose the ability to perform precise comparisons for the bars at the top. Here is the stacked version of the side-by-side bar chart that we showed a couple of slides ago. Again, the categories are different animals, giraffes, orangutans, and monkeys. And the two groups that we are comparing against each other are LA Zoo and San Francisco Zoo. This stacked bar chart is easy to understand, but we have to be careful not to add so many groups to our stacked bar charts. As you can see, here we achieve some part-to-whole visualization, but we are losing our ability to precisely compare the groups against each other. Also, it is harder to compare the number of animals in the top category, meaning LA Zoo, since the baseline for each bar is different. Instead of using stacked bar charts, in many situations, side-by-side or group bar charts are preferred. A diverging bar chart uses height or length from a baseline with the bars diverging from the center. Diverging bar charts provide a precise quantitative comparison for each diverging group, meaning here the blue bars can precisely be compared to each other, and likewise the gray bars can precisely be compared against each other. At the same time, diverging bar charts allow for relative comparisons of the groups as well, meaning the blue bars versus the gray bars. Here is the diverging bar chart of the same zoo data. Again, we have three categories of animals and we have two groups, LA Zoo and San Francisco Zoo. As you see, there is a midpoint or a divergent line which can be 0, an average, or an expected number, and the bars for the two groups expand in the opposite direction of each other. The drawback of using diverging bar charts is that it's not easy to compare the values between groups like we can do in group bar charts. So the between group comparisons are just relative and not precise. Still, the comparisons are more accurate than stacked bar charts because for both groups we have a common baseline. The examples that I'm showing here are all considered diverging bar charts, although there are some differences in their structure. As a variation of a bar chart, bullet charts are an excellent tool to show an actual value compared to a target value. Bullet charts use height or length from a common baseline for the actual values, and they use position to make a comparison to a target, which is shown by a line. This one here or this one here. Color can also be used to show performance bands so that the actual values can be shown with respect to desired performance levels. Here we have 3 performance levels shown by 3 shades of gray. Here is an example in office supply sales, where the performance bands show 60% and 80% of the goal. And here is the actual value that exceeds the goal, which is represented by this red line. So again, for the actual value, we are using the length of the bar as the pre-attentive attribute. For the target value, we are using the position of the red line here. And for the performance bands, we are using color as our pre-attentive attribute. And here is another example of visualizing sales versus forecast sales for coffee, espresso, herbal tea, and tea in different markets. In this example, when we hit and exceed the forecast, the bar is drawn in blue. And whenever we miss the target, like this one, the bar is drawn in orange. See, the target is here, and we were not able to hit the target. Hence, we are using the orange color in this chart. Bullet charts have many applications in financial analysis. They provide 2 types of context comparing to standard bar charts. The first context is the target value, and the second type of context that they provide is the performance bands, which are excellent for comparison against similar data. Let's say comparisons against last year's data. All right, good enough. We will continue our discussion in the next lecture, going over waterfall charts, dot charts, Gantt charts, histograms, and box plots. I will see you soon.